And now that we have established a distribution and a standard error formula, the process for finding a confidence interval for a mean follows a very familiar pattern. We have our sample statistic, which is now always x bar, plus or minus our margin of error, which we're going to get by using a t-star critical value, and multiply that t-star critical value by the standard error. So sample statistic plus or minus margin of error, just like we are used to. T-star is the critical value for a t-distribution with n minus 1 degrees of freedom. We sometimes write that as t with n minus 1 in parentheses. Sometimes you'll see that as t sub n minus 1. That just means a t-distribution with n minus 1 degrees of freedom. Same standard error formula that we use in other places we also use for a confidence interval. So here let's go ahead and use the same data set and estimate the mean kitten weight from a FeLV positive mother. First thing is the standard error, which we've already calculated once before. Our SE is S over square root of n, which if we look at our prior calculation, we see comes out to be 3.0535 is the calculation that we found when we were doing a hypothesis test for these data. So next we need to look up our t-star critical value, which we typically do in a table. It is also possible to do this in StatKey. Let's go ahead and do it both ways just once. But as long as it's a 90%, 95%, or 99% confidence interval, it's usually easier to just look it up in a table. So here's what we want to do. We say we're working with 9 degrees of freedom, so I'm going to only look at this row of my table. And since I also want, in this case, a 95% confidence interval, I'm going to only look in this column. And so putting those two things together, the intersection comes out to be right here, 2.262. So that is my t-star value. Now let's find that in StatKey as well. Coming to theoretical distributions T, again, I'm going to choose 9 degrees of freedom. And now I'm going to, just like I was doing confidence intervals back in our bootstrap section, I'm going to select two-tail and make sure that the center is set to 95%. I can see down here this value says 2.262 when I'm looking down here at the bottom. I'm trying to find the boundary of that tail, really, right? So I can also get this from StatKey. Now my confidence interval for the mean, I need a margin of error, and my margin of error is t-star times the standard error. So that's going to be 2.262 times 3.0535. And that comes out to be 6.907. Then I'm ready to do x bar plus or minus the margin of error. My x bar in this case we found earlier to be 92.51. So now I will add and subtract my margin of error of 6.907 to get my confidence interval. It's not really an absolute rule for the amount of rounding to do on something like this, but since my original data were only given to 1 decimal place, it makes sense to give my confidence interval also to 1 decimal place. Taking it a little bit further than that would be fine. So what we want to do now to interpret our confidence interval is to make sure it's clear we're talking about a mean, and to know that this mean is measured in grams because the kittens' weights were measured in grams, and we want to indicate that the mean kitten weight is between these two values, at least for our population, which is all kittens born to a FeLV positive mother. We do have some practice at this stage at interpreting confidence intervals, but some of the things that are really important are worth mentioning again. Make sure that we include the word mean or average. This is a statement about mu. This is not a statement about all of the kittens born to FLV positive mothers. Only a statement about the average. Make sure that we indicate the population, right? That our description is for a population, not a sample, and that we're clear about what that population is. And also make sure that you remember to put units on your numbers that are the boundaries of this confidence interval. Including the with 95% confidence is nice, but it's not the most critical part of this by far. If you were to leave that out completely, I really wouldn't mind. I think the most important thing is illustrating that we know what this confidence interval really means.